Now, let's do a problem to master this concept. The problem is this. Hans can paint in 3 hours, paint this fence. And Adriana can paint this fence. They are the same fence, takes same amount of work. Can paint in 2 hours. Okay, what do we do now? They are asking, how many hours would it take if they painted together? In the SAT and ACT test, choice A will be 5 hours. An amazing number of students fall for it. How could it be 5 hours? Should be less time, right? Working together, unless they start fighting. Why should it take longer? Okay, but how much shorter is the question? That's what we'll learn. This is how we do the 3 steps that I showed you before. Work is rate times time. So how do you express this work in math here? It's one fence set. Often, if it's painted one house or filled in one swimming pool, you would just put one there. One work. How fast did it work? I don't know. There's a rate of Hans here. How long did it take? 3 hours. Okay, there's one work here. What about Adriana here? This is Hans' story. And Adriana's story is she's painting one fence. And how fast is she working? Working at rate of Adriana times 2. Now notice here, the problem could be quite twisted. You may say Adriana can paint 6 fences in 11 hours. Not to be afraid here, just put 6 fences and 11 hours here. So writing in this form, you're just bulletproof. No matter what they say, you can just put down what they say. It could be 1.5 houses in 3.5 hours. No problem. 1.5, 3.5, like that. Okay. We did that. It's number 1. Number 2, working simultaneously means adding the work. How do we add the work? Well, we got to add the work. How do we do that? It's this. The work is what? Rate times time. So we are going to do rate times time. How long will they take to paint the fence together? How should I know? That's the question. So let's say it will take T to do it together. So let's make them work together. What is Hans's work? Hans works at R sub H. And he's going to work for T, the time that it takes for them to paint together. See, that's Hans' work. This is work by Hans. And then, how much work will be done by Adriana? At Adriana's rate, she will work for T. So this is work done by Adriana. See, I'm adding the work. And that, they are working shorter time because they're working together and they are working together to paint one fence. So each one painted less than one fence, you see. But combined together, they painted one fence. In other words, work was one fence. There we go. That's all there is. Okay. Well, you may say, oh, what's all there? What is? I got lots of variables here. But you know what they are, right? R sub H is 1/3 times T. And then, what was the other one? R sub A is 1/2 times the time. In other words, 1/3 plus 1/2. T is the work, 1. That's what I meant by, if they worked the same amount of time, in other words, if they share T here, you can add the rate to save a step. You could have gone from here to here straight. I just added their rate here, right? Okay, that's all there is. So that's what you have. 1 equals that. So let me write it here. 1 equals 1/3, 2, T. So what is T? To make our life easier, let's add these fractions. It would be 5/6. If you don't know how to add these two, you should be worried. T equals 6/5. So it takes 6/5 hours. That would be 1 hour and 12 minutes. But probably your test would have this choice. Or you can just put down as 6/5 hours. So that is the answer. I want you to verify a few things here. She can paint the whole thing in 2 hours. If somebody helps, it should take even less time with a helper, right? So you, first of all, if you're totally lost here, you should look for an answer that is shorter than the shortest time there is. He takes 3 hours. She takes 2 hours. Alone, she can finish in 2 hours. If somebody helps, should be even less. But an amazing number of students would go for 2.5. That's amazing. Okay. And if you're experienced in this type of problem, you will go straight to this part. Another thing I'd like to show you is that this is later in your life, you will add resistance in parallel circuit. That's how it is done. 3 ohm, 2 ohm. If you have a parallel circuit, this is how you add them. Okay, now I'd like to mention one more thing. What if they didn't work together? Suppose he arrived 30 minutes late. Then how would you solve the problem? In that case, the t is not shared, you see. I used the same t here because they work together. What if he arrived 30 minutes late? Then what do we do? Then his time will be 30 minutes less. In other words, would be minus 0.5. That's how we do. So even if they, of course, then you cannot go straight here. That's why I said if they work the same amount of time, only then you can dive in here. Fortunately, about 80% of the problems in math class you will do is usually working together like that. But in some hard problems, they arrive late, they leave early, and all that. If they worked they worked for different duration of time, then this is where you tweak and adjust the amount of time. But in no problems, their rate will change. A person doesn't change. His hours may change, but how fast he works, we assume it doesn't change. So we can keep these rates clearly. So when they're telling you the problem, Hans can paint in 3 hours. They are in disguise telling you what the rate is, so that you can use it in later time.